Okay, so today we're going to be doing the maximum average subarray question on LeetCode, and this is my solution for it. So here's the question. If you're given an integer array nums consisting of n elements and an integer k, find a contiguous subarray whose length is equal to k that has a maximum average value and return this value. So essentially what they want us to do here is that they want us to look at a quote-unquote window and find the sum of it, and then find the value that has the largest average. Find the sum of the window that has the largest average. So for example, they gave us 112 minus 5 minus 6, 53. The output would be 12.7. That's because the largest continuous window would be right here, where they have 12 minus 5 minus 6 plus 50. So we see that that would give us, and then you divide it by 4 to get the average, which would be k, and that's how you get your answer here. So constraints, nothing really. We don't have to look out for if the window size is 0, so that it's pretty straightforward in terms of the constraints. So look at any question now. So I actually got a little bit of trouble with this one. I'll go through the one that I thought worked, but it didn't. It ran out of time. So if we just look here, we see the input is the integer array k and the integer. The output would be integer array as well. No, it wouldn't be an integer array, just be an int. So the continuous. So basically, what they're asking is to find a continuous array of length k whose average is the greatest in the array. So many cases would be if k is the length of the array, in which case it's just the sum of the array that we're finding. Well, the average of the sum of the array, the entire array. If k is anything less than the array length, then we have to do a window. So this is the pseudocode for the correct answer that I have, but I just want to run through very quickly an incorrect implementation that I had. So I actually got kind of confused in terms of, well, not confused, but I had a non-optimal way of doing it, because I was very aware of the fact that it was a sliding window, but I wasn't entirely sure about how to go about doing it at first. So I got a little bit of trouble here. So my initial implementation was to continuously recalculate the sum of nums at the start and end, and increment the end and the start by 1 for every iteration. And basically what ended up happening here is that there was even though it ran 3 test cases, in the actual submission it ran out of time, and the reason for that was because it was recalculating what the sum was every single time, and if k gets really big, or if the array gets really big, then it just it times out. So what I had to do was that I had to try and find a way to implement that sliding window a little bit better. I thought that just by incrementing the end and the start, that would be enough to technically be considered a sliding window, but it wasn't enough. So let's go through correct implementation here. So the first thing we want to do is initialize window. So to initialize the window, we get the sum of the initial window, which would be from 0 to k in the nums array, and then we get the sum of that, and we set that as the max window, which would be our baseline. Then for I in range k, starting at that, we make a loop here for I in range starting at k to length of nums. We want to just basically go through and add the number to the right of the window and remove the number to the left, and that's how we're going to get our sliding window. So I will start at k, and it would go to the length of nums. So to get the value of the left would just be I minus k, and then to get the value of the right would just be I. So, and then we recalculate the sum, and we get the greater of the initial window sum, or if this here is greater. So going through the code here. So we see we initialize the window at first. So the initial window would just be sum of nums 0 to k, and then we set the max window sum to that sum. As we go into the loop, we start at k, and we do length of nums. We go on until the length of nums. we start off by first removing the value at nums I minus k, which would be the element to the left, and then we add the element on the right, which would be windows plus equal nums I, and we recalculate the max window sum given the new window and also the max window sum, which we would have initially initialized, or if it gets replaced at any time during the loop. Also, to save time, you actually don't need to recalculate the average every single time, because if the sum is the greatest, then it will just be the great, because k doesn't really change. We don't have to worry about the average being recalculated every time. We just need to get the max, and then the average will follow as being just over k. So that was kind of how I went through it. It would be of the space complexity would be it would be ON, I think. Not ON, it would be ON. It would be ON, I think. I'm not too sure, but the time complexity, we're going through the array once, so it would be of ON. Yeah.